Now in part B, we have 4 root 2 cis negative 3 pi by 4. Let's just think about where that would be before we go ahead. So the argument is always measured from the positive real axis. So negative 3 pi by 4 is measured in a clockwise direction. So this complex number is going to be here in the third quadrant. Now we can use that as a check on our answer just to make sure it's in the right place. So that's 4 root 2 cos negative 3 pi by 4 plus I sine negative 3 pi by 4. So that's 4 root 2 cos negative 3 pi by 4 plus 4 root 2 I sine negative 3 pi by 4. Now let's think about these. So 3 pi by 4 is related to the standard angle of pi by 4, or 45 degrees, and we know cos pi by 4 would be 1 over root 2, or root 2 over 2, but it's easier to use it in this form. And sine pi by 4 is also 1 over root 2. Now down here, for negative 3 pi by 4, we're in the t quadrant. So both of these are going to be negative. So that's 4 root 2 negative 1 over root 2 plus 4 root 2i negative 1 over root 2. Cancel the root 2's here. And what do we end up with? We've got negative 4 take away 4i. Negative 4, negative 4, so we're in the right quadrant. Now in part C we have 5 cis pi by 2, which is 5 cos pi by 2 plus I sine pi by 2. So that's 5 cos pi by 2 plus 5i sine pi by 2. Well, the sine of 90 degrees is 1 and the cos of 90 degrees is 0, so that's just going to be 5i. Let's think about an argument of pi by 2. So that's 90 degrees around from the positive real axis, which makes the number on the imaginary axis. So this makes sense. And then we have 3 cis negative pi, which is 3 cos negative pi plus I sine negative pi. So that's 3 cos negative pi plus I sine negative pi. Now negative pi is here. Now we should use what's known as a principal argument. So that's the same as having 3 cos pi plus I sine pi. Puts it in the same place. Now the cosine of pi is negative 1, the sine of pi is 0, so this is negative 3. And if you look at the diagram, this is the correct place for negative 3.